Welcome to Virtual Petroleum Laboratory. I am Professor Uttam. Today we will show or demonstrate a flashpoint apparatus for fuel oil, kerosene and diesel, which are important for petroleum laboratory. Now you can see there is a heating system over which a vessel is being placed, in which a cup is being inserted with a required amount of sample oil for the fuel oil or kerosene or diesel and any other petroleum product. And there is a continuous sparking device that as soon as you have started, this sample will be filled and then sparking will be continuous. Almost every 30 seconds, sparking is done, and as the vapor of the petroleum oil will reach here, at a certain temperature it will start flashing. So this minimum temperature at which the first flash is obtained is called the flash point, and then after some time you will find that the flash will be continuous into a flame, and then it is called the flame point corresponding to this temperature. So we measure the flash point and flame point or fire point by this temperature at which it is measured accordingly for the first flash and continuous flame. Now we start with fuel oil. So take the sample fuel oil. Now you start the heater on, so temperature is increasing and flashing is continuously done every 30 seconds or quicker. So you also observe the temperature here with the thermometer. It must be noted at which the first flash will be obtained. That will be the flash point. Just wait. This is for fuel oil. Till there is no flash. (42) is the minimum temperature. 42, 43 is minimum temperature, which is flash point. And now wait for the continuous flame. (66) you will find that the continuous flame has been produced and sample is completely exhausted. So that is the way of experiment for determination of flash point of any petroleum product. Now you put it off and you select kerosene in the cup and then start the heater as well as the auto sparking system. It could be done manually also by introducing spark like this. It's better to have a continuous system. Automatic system is much better. So the auto sparking is done, and look at this temperature at which the first flash will be obtained is called the flash point. Now this is for kerosene. So we have not observed properly, so we start it again for the kerosene. We repeat this experiment. Seven, 8, 9, 10. Be careful when it is 30, we just observe it. Look at this, where the flame is produced. So it is 36 is the flash point, is the first temperature, and then look for continuous flame. Temperature is 46 around. So that is the 35 and 40, 45 or 46 is a flame point or fire point. and 35 or 36 is the flash point of kerosene. Now put it off and you take diesel. Now again the cup has been filled with this diesel and start this heater on, and temperature is noted, flashing is sparking is started, electrical sparking is done. At the minimum temperature some explosion or this spark flame will be produced. That is your flash point, so it's called flash. So just look at this temperature at which it's happening for diesel. So 55 or 56 is your flash point for the diesel, and flame is constant at 63 or 62. 62 or 63 is your flame point or fire point for the diesel. So this way you can carry out the experiment in the laboratory, in the real laboratory. It's a virtual system, that's just a demonstration how this experiment is carried out. And there is a standard system according to ASTM, the heating rate and the position of the thermometer, the amount of the sample in the cup, and this sparking system, everything is standardized. And this is open to atmosphere, it is a open cup system. There is a closed cup system also, I am not going to explain that. This is only very simple experiment that can be done for determination of the flash point as well as fire point. This is required for classification of the hazardous materials like petroleum products, and classification as well as for storage and for usage. This flash point is very important, and fire point. So this is the simplest experiment which can be carried out in the laboratory for determination. Thank you very much for observing this video.